Hello, Professor. My name is Phan Thị Thiện. My student ID is 114851444M. So today I will talk about the very important technology called smart contracts. I want to explain how they work and why they are the future of digital agreements. So imagine you're buying a house. Usually this involves a mountain of paperwork, escrow agents, lawyers, and weeks of waiting. Now imagine if that entire process was handled by a computer program that automatically transferred the deed to you the moment your payment was verified, without any middleman taking a cut or slowing things down. This isn't science fiction, this is a world of smart contracts. So today we're going to break down what they are, why Ethereum changed everything, and how this technology is rewriting the rules of trust on the internet. So to understand smart contracts, the first have to understand Ethereum. While Bitcoin was designed to be digital gold, a way to move value, Ethereum was designed to be something much bigger. Launched in 2015 by Vitalik Buterin and a team of developers, Ethereum is often called a world computer. Unlike a normal computer owned by Apple or Google, Ethereum is decentralized. It runs on thousands of computers worldwide simultaneously. This means it has no single point of failure and cannot be shut down by any single entity. Most importantly, Ethereum introduced a Turing-complete virtual machine. In simple terms, it allowed people to write and run code directly on the blockchain. This code is what we call a smart contract. So what is a smart contract? The term smart contract was coined by Nick Szabo in the 1990s. Long before blockchain existed, he used the analogy of a vending machine. So think about it. A vending machine is a physical contract. If you provide the correct amount of money, the input, the machine is programmed to give you the snack, the output. You don't need a cashier or a lawyer to stand there and verify the transaction. The machine's hardware and logic is the contract. So in the digital world, a smart contract is a program stored on the blockchain that runs when predetermined conditions are met. It's an if and then statement that is set in stone. So how smart contract work? Let's look under the hood. How does a piece of code actually work on a blockchain? The code is a developer writes a contract, usually in a language called Solidity. The code is uploaded on the Ethereum network. Once it's there, it is public and cannot be changed. The trigger, the contract sits dormant until an event happens, like someone sending a payment or a specific date passing. Execution, the network nodes, like the computers running Ethereum, verify that the conditions are met and execute the command automatically. To prevent spam, users pay a small fee called gas to power these computations. The key features of smart contracts. What makes these better than a PDF or a paper contract? There are 4 key pillars. First, automation. There is no waiting for the check to clear or waiting for HR to process the payment. Execution is near instantaneous once conditions are met. Second, trust minimization. You don't have to trust the person you are dealing with. You only have to trust the code. The math and the network consensus ensure the outcome is honest. Third, transparency. Every smart contract on Ethereum is public. Anyone can inspect the code to see exactly how it works before they interact with it. There are no hidden clauses in the fine print. Finally, immutability. Once a smart contract is deployed, it cannot be edited or deleted, not even by the person who wrote it. This provides a level of security and certainty that traditional legal systems struggle to match. So applications in the real world. So what can we actually do with this? The biggest use case today is DeFi. Smart contracts allow you to lend or borrow money without a bank. The contract holds the collateral and automatically pays our interest. In supply chains, a smart contract can release payment to a supplier the second a GPS sensor confirms the shipment has arrived at a warehouse. And for NFTs, smart contracts ensure that artists receive a percentage of royalties every time the digital art is resold in the future. We also see DAOs, decentralized autonomous organizations. These are companies run entirely by smart contracts where shareholders vote on how to spend funds and the code automatically executes the winning vote. Risks and imitations. But it's not all perfect. Smart contracts come with significant risk. Since the code is immutable, if there is a bug or a logic hole in the contract, hackers can exploit it to steal funds. We saw this with the famous DAO hack in 2016. The Oracle problem. Smart contracts cannot easily see the real world. They need oracles, third-party data feeds, to tell them things like who won the football game or what is the price of gold. If the oracle lies, the contract fails. Legal status. Most governments are still figuring out how to handle smart contracts in a court of law. If a contract executes a trade that is technically illegal, who is responsible? Conclusion. Smart contracts are the building blocks of a new, decentralized internet, often called Web3. They replace expensive, slow intermediaries with fast, neutral code, while the technology is still young and carries risks. The rift toward programmable trust is irreversible. So thank you for watching. If you have any question, please reply.